Let us solve one more theorem on pair of straight lines. This theorem is actually deals with the point of intersection of pair of lines ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So, that means in order to find out the point of intersection of the pair of lines, so let us assume that x1 comma y1 be the point of intersection of the pair of lines, which is represented by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So, then now we need to translate the origin to the point x1 comma y1 without actually changing the directions of the x and y axis, coordinate axis. So, then we get the capital small x is equal to capital X plus x1, small y is equal to capital Y plus y1. So, then we get the transformed equation by substituting small x for capital X plus x1, small y for capital Y plus y1. So, according to the problem, the transformed equation is passes through the origin. So, whenever the equation actually passes through the origin, it must be homogeneous equation. It should represent homogeneous equation, which is in the form of a capital X square plus 2h capital xy plus b capital Y square is equal to 0. So, that means now, so when we substitute, we need to equate x and y coefficients to 0, so that we get the two equations. By solving the two equations, we get x1 y1, which is nothing but the point of intersection of the pair of lines. So, this strategy is to be followed to find out the point of intersection of the pair of lines ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. That is hf minus bg by ab minus h square, comma gh minus af by ab minus h square, and providing h square must be greater than ab. So, now, so let us solve this problem now. So, here given this is the ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Say equation 1 this is. Let p x1 comma y1 be the point of intersection of equation 1. Now, let us translate the origin to the point x1 comma y1. So, now let us translate origin to the point x1 comma y1. Now, the equations of transformation becomes like this. Small x is equal to, we can write capital X plus x1, and the small y becomes capital Y plus y1. That means x comma y are the here original coordinates, capital X comma capital Y are the new coordinates, whereas x1 comma y1 is the origin. Already we have discussed in transformation of axis. So, now equation becomes, in the place of x replace capital X plus x1, in the place of small y let us replace capital Y plus y1. We get transformed equation is as follows. So, now we get a multiplied by capital X plus x1 whole square. Okay, am I correct? Plus 2h multiplied by capital X plus x1, and this is capital Y plus y1, and plus b into capital Y plus y1 square plus 2g of capital X plus x1 plus 2f capital Y plus y1 plus c equals to 0. Now we need to simplify this one. So let us simplify it. This is a plus b whole square form. So a square plus 2ab plus b square we can apply. So a times capital X square plus 2x1 into capital X plus x1 square. Am I correct? So let us multiply these two now. Plus 2h times capital X into y capital XY plus capital X into y1 capital X y1 plus capital Y into x1 plus small x1 and y1 plus b times this is capital Y plus y1 square. So this is also in the form of a plus b whole square, so that we get now capital Y square plus 2 y1 into capital Y plus y1 square, and plus this can be written now 2gx plus 2gx1 plus 2f capital Y plus 2f y1 now plus constant c equals to 0. So now let us write first in terms of capital X and capital Y. Later we shall write it in terms of small x1 and small y1. So let us actually regrouping the terms. Now we get like this: a capital X square plus 2h capital XY. Okay. Now plus b capital Y square. Next now 2a x1 capital X plus 2h y1 capital X, and we have here also capital X plus 2g capital X. In the similar manner, so we can write now 2hy 2h x1 capital Y. Okay. Next we have here 2b y1 capital Y plus this 2f capital Y. So now the rest of the terms need to be written. We have ax1 square, that will be very simple. So in the place of left hand side, put x for x1, y for y1. We get that is ax1 square plus 2hx1 y1 plus by1 square plus 2gx1 plus 2f(y1) plus c equals to 0. So now ax square plus 2hxy plus by square. Now what shall we do? Here from 2ax1 capital X plus 2h capital y1 into capital X plus 2g capital X, let us take capital X common. So when you take the capital X, even 2 capital X also we shall take out common. So when you take the 2 capital X common, we have 2 times ax1 plus hy1 plus g of capital X. Let us check it. So, in the similar pattern, from the next three terms, let us take 2 capital Y common. So, we get now 2 times hx1 plus by1 plus f of capital Y plus ax1 square plus 2hx1y1 plus by1 square plus 2g x1 plus 2fy1 plus c equals to 0. Okay. This we can write it. Okay, now see, according to the problem, it should pass through the origin, that is new origin, that is x1 comma y1. As the pair of lines passes through the origin, it must be in the form of a capital X square plus 2hxy plus by square is equal to 0 only. So, that means this x coefficient should be 0 and y coefficient should be 0 and constant term should be 0. So, that means as it represents a pair of lines passes through new origin x1 comma y1. So, it should be in the form of a capital X square plus 2h capital Xy plus b capital Y square is equal to 0. So, that means now in order to keep in this form ax square plus 2hxy plus by square is equal to 0, the coefficient of capital X and coefficient of capital Y and constant terms need to be equated to 0. So, now equating coefficient of X, coefficient of Y and constant terms to 0. We get see, this must be 0 and this must be 0 and this must be 0. So, now we get ax1 plus hy1 plus g must be 0, say equation 2, and next hx1 plus by1 plus f is equal to 0, say equation 3, and next ax1 square plus 2hx1y1 plus by1 square plus 2gx1 plus 2fy1 plus c must be 0. This is fourth equation. Okay. Now, solving 2 and 3, we get x1 comma y1 value, that is the required point of intersection of the given pair of lines. So, that means now we need to solve 2 and 3. Solving equations 2 and 3. We get x1 comma y1, which is the required point of intersection of the pair of lines. Solving means actually here we can adopt the cross multiplication method. Here we can write ax1 plus hy1 plus g equals to 0. This is 2. Okay. hx1 plus by1 plus f is equal to 0. Say 3. Applying cross multiplication method. Applying cross multiplication method. Okay. So now we can write the questions like this: h g a h b f h b. Here x1, y1 and 1. Now we get x1 by the determinant of this 2 by 2 matrix, hg bf, hf minus bg, correct, equals to y divided by the determinant of this matrix gafh, that will be gh minus af, equals to 1 divided by the determinant of this matrix. So we have ab minus h square. Now this we can write like this: x1 by hf minus bg equals to, equating first and last, that is 1 by ab minus h square. So x1 is equal to, we can write hf minus bg by ab minus h square. So now that means equated this one. Now let us equate these two now. y1 by gh minus af equal to 1 by ab minus h square. Now let us find out the y1 value here. So y1 equals to gh minus af divided by ab minus h square. So now therefore point of intersection equals to x1 comma y1. So let us write it as a order pair. So now we can remember like this: hf minus bg by ab minus h square comma gh minus af by ab minus h square, providing the h square greater than ab. So in this way we can find out the point of intersection.